final new material for the course is solving quadratic equations using the quadratic formula. So in this lesson, we're going to figure out how to use the quadratic formula to solve quadratic equations. We're going to identify quadratic equations with no real number solutions, determine the most efficient method to solve a quadratic equation, and solve problems modeled by the quadratic equation. So in order to use the quadratic formula to solve quadratic equations, we have to start by looking at the equation. So this is getting us to the equation. Basically, we're starting with a situation where we have ax squared plus bx plus c. So we've taken everything to the left side of the equation, left it equal to 0 on the right-hand side. Once they've done that, they divide everything by a. After divide everything by a, they take this c over a to the other side. Then they can say, since the coefficient of x is b over a, they use completing the square, which is a method we haven't really talked about in this section, but basically makes it so that you can factor the left side easily. So they add the same thing to both sides, b squared over 4a squared, b squared over 4a squared. Eventually, when they subtract, they get it out to be x plus b over 2a squared equals b squared minus 4ac over 4a squared, which is very close to what we want. Then, basically, they rearrange things so that they look at x plus b over 2a equaling the positive root, or they look at x plus b over 2a equaling the negative root. By taking the bottom under the root 4a squared, we can take that out as a 2a. So essentially, what that allows us to do is to take this b over 2a added to the root of b squared minus 4ac over 2a with a common denominator, and allow us to arrive at this final form that we're hopefully used to seeing before. If you haven't seen it before, that's perfectly fine. You're going to get very used to seeing it. But basically, we wind up with x equals negative b plus the root of b squared minus 4ac over 2a when we do it this time with the positive version. When we do it with the negative version, we get the exact same thing except for this sign. Over here it's a positive, over here it's a negative. So essentially, we're led to two different roots from the formula, but the formula ends up looking the same, just with a plus here, with a minus here. That's why when we use the final formula, you see it as plus minus. Plus minus tells me that there's two distinct roots that I'm getting to. The only time that that's not true is if this whole thing under the square root equals 0, then really adding or subtracting 0 gets me to the same thing. So in most cases, it's going to get me to two different answers, one when I follow the positive, one when I follow the negative. But this overall equation definitely needs to be in your notes, and we need to get used to plugging in letters and solving for x. So let's say we start out with x squared plus 5x plus 6, and we want to use the quadratic formula in order to solve for the factors here. This is a case where I could solve it more easily by factoring using the methods we've learned earlier in the course, but the reason that we're going to do it by the quadratic formula is because you're going to see how it gets us to those same answers with the formula, where we're not going to have to use factoring to do it. Instead, we just have to follow through and plug things in where they belong, and it'll lead us to those same two answers. That way, when we get to something that's not factorable, we can use the same methods and get to an answer that's going to be a decimal answer or a fractional answer that we wouldn't be able to get otherwise. So the first thing we need to do when we get an equation like this is make sure it's set equal to 0, with first the x squared term, then the single power of x, then the no power of x term. This is in the proper order, so we can now go to finding a, b, and c. So to identify a, b, and c, we look in front of the x squared term, we see there's an understood 1, and we write that down as what a equals. We look in front of the x term, see there's a positive 5, we write that down as b, and the term with no power of x is 6, we write that down as c. Now that we've identified a, b, and c, we're really done with the original form of the formula. We want to now plug in that a, b, and c to the quadratic formula. So where we see negative b, we're going to put in this 5, and it's going to become negative 5. Plus or minus, we're going to square the 5, minus 4 times 1 times 6 all over 2 times 1. There's everything plugged in the proper positions. Now we have to resolve things. I recommend you start under the root. So the first thing that I want to do is square out this 5 and do 4 times 1 times 6. When I do that, the 5 squared gives me 25. 4 times 1 times 6 gives me 24. So under the root I have 25 minus 24. The only other thing we really cleaned up was doing 2 times 1 on the bottom to just get a 2. When we now do the subtraction under the root, it leaves us with the root of 1, which is a perfect square and can come out of the root as 1. We now have two possible answers, negative 5 plus 1 over 2 and negative 5 minus 1 over 2. So once I get it to this step where I have the root all resolved and the numbers come out of the root, I need to split it into a positive answer and a negative answer. For the positive answer, it's negative 5 plus 1 over 2. For the negative answer, it's negative 5 minus 1 over 2. So again, all we've done is taken what came out of the root, and one time on top we're subtracting it, one time on top we're adding it. When we do it the way that we're adding, we get negative 4 over 2, which reduces to x equals negative 2. When we do the one where we're subtracting, we get negative 6 over 2, which reduces to x equals negative 3. This gives us two valid solutions, negative 2 and negative 3, which would have been what we got by factoring. If you remember the original equation is x squared plus 5x plus 6, it would have factored to x plus 3x plus 2, which would have meant to make it 0, we would plug in either a negative 2 or a negative 3. These three problems I'm now going to try out on the whiteboard and show another few examples of how this quadratic formula can be implemented. When I go to do this first problem, it's already been set equal to 0, so I can pull out a, b, and c. A equals 1, and understood 1 in front of the x squared. B equals negative 7, and c equals 10. When I put this into the formula, x equals the opposite of b. Since b is currently negative, the opposite of a negative is a positive. So 7 plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. When I go to do the next step of simplifying, the 7 stays, plus or minus the square root. Negative 7 squared gives me 49. Remember, you always need to get a positive answer when you square something, so that negative is being multiplied by itself as well. Negative 4 times 1 is negative 4, times 10 is negative 40. All still over 2. This becomes 7 plus or minus the root of 9 over 2, which goes two different ways. Since the root of 9 is 3, we have the top version, 7 plus 3 over 2, and the bottom version, 7 minus 3 over 2. In the top version, 7 plus 3 is 10, divided by 2 gives me 5. In the bottom version, 7 minus 3 is 4, divided by 2 gives me 2. So my final answers for x are x equals 2, 5. When I go to do part B, again, it's set up in decreasing order, x squared term, x term, no power of x term, and set equal to 0. So I can pull out my letters. A is in front of the x squared term, it's 7. B is in front of the x term, it's negative 11. And C is the number with no power of x, it's 2. When I plug this into the formula, the opposite of negative 11 is positive 11, plus or minus the square root of negative 11 squared minus 4 times 7 times 2, all over 2 times 7. When I go to do my next step, 11 stays, plus or minus the square root. Negative 11 squared should give me 121. Minus 4 times 2 is 8, times 7 is 56. So 121 minus 56, all over 2 times 7, which is 14. 121 minus 56, so if I subtract 6 from that, I get 115 minus 50 is 65. So this becomes 11 plus or minus the root of 65 over 14. There's no real way to simplify 65, so really I would leave this like this if I was doing a written test. I think in Cengage, they probably want you to go to the next step and break it up into 11 plus root 65 over 14 and 11 minus root 65 over 14. You could put these in your calculator like this to get decimal answers as well. For part C, we're going to pull out A equals 8, B equals 3, C equals 5. When I then set up my formula, x equals negative b, the opposite of a positive 3 is a negative 3, plus or minus the square root of 3 squared minus 4 times 8 times 5, all over 2 times 8. When I go to the next step, it becomes negative 3 plus or minus the root of 3 squared is 9, minus 4 times 5 is 20, 20 times 8 is 160, all over 2 times 8, which is 16. When I get to my next step, I realize that under the square root, I have 9 minus 160, which gives me a negative number, specifically negative 151. At this stage, I can recognize negative 151 is not a real number. That would get me to an imaginary number, which means this does not have any real roots. When there's no real roots to the problem, you write as your answer, no solution. So as soon as you get to resolving the root and you realize that there's a negative number under the root, that's when you can stop and say there's no solution to the problem. We're going to talk about how to identify quadratic equations with no real solutions by looking at the discriminant. So if we want to figure out, does the equation x squared plus 2x plus 5 equals 0 have any real number solutions? Where we'd want to start is by identifying a, b, and c in the equation. So in this case, a equals 1, b equals 2, and c equals 5. What we really care about is what's happening here under the root. What's going to determine how many real answers I have is whether what's under this root is positive, negative, or 0. If it's positive, I'll have 2 real answers. If it's 0, I'll have 1 real answer. And if it's negative, I'll have no real solutions. So looking under this root for what's called the discriminant, b squared minus 4ac, is really going to tell us what's going on as far as how many solutions there should be. If I do out 2 squared minus 4 times 1 times 5, 2 squared is 4, minus 4 times 1 is 4, times 5 is 20. 4 minus 20 is going to give me negative 16 or a negative answer. That's how I'm going to know there's no real solutions to the problem. So here you can see I get 4 minus 20, which becomes negative 16. Since the result under the radical symbol is a negative number, negative 16, it means there's no real number solutions to the problem. So really they went through and did everything else in the problem. They didn't need to. You can focus right here on what's happening under the root in order to answer the question, how many solutions did this have? Here's 3 more examples that we're going to end with by going over how to find the different number of solutions in 3 different types of problems. When we concern ourselves with how many real solutions, our focus is going to be on the discriminant. The discriminant is this part of the quadratic equation, the part that's occurring under the square root. So when we go to find how many real solutions there are, we look at the equation b squared minus 4ac. That b squared minus 4ac is going to be one of 3 things. If it's positive, then there's 2 solutions. If it's 0, there's 1 solution. and if it's negative, there's no solutions. So, when we go to the first problem, we identify what A is. A equals 1, B equals negative 10, C equals 25. We can now check B squared minus 4AC. B squared is negative 10 squared minus 4 times 1 times 25. Negative 10 squared is 100 minus 4 times 1 is 4 times 25 is also 100. We get 100 minus 100 equals 0 as the answer to our discriminant. When the discriminant is equal to 0, that's when we have exactly one solution. So I would say one solution as the answer to this problem. In part B, we set up the same general idea. We pull out A equals 7, B equals 6, and C equals 2. If we then set up the discriminant, this discriminant should be B squared, or 6 squared, minus 4 times A, which is 7, times C, which is 2. 6 squared gives me 36. 4 times 7 gives me 28. Times 2 gives me 56. So I get negative 20 as my answer. When I get a negative answer, that means there's 0 solutions. For the final problem, again, I start by pulling out A equals 12. B equals, since there's no number in front of the x, it's an understood 1. And C equals negative 9. I can now set up B squared, or 1 squared, minus 4 times 12 times negative 9. 1 squared is just 1. Negative 4 times a negative 9 is a positive 36. Positive 36 times 12 would give me 360 plus 72. So that would give me 332. The key is really that this negative and this negative multiply to make a positive. So I'm adding something positive to something else positive. I get an answer of 333, but what's really important to the problem is that I got a positive answer. Since I got a positive answer, the correct answer to their question is 2 solutions. So in each of these 3 cases, we looked at the discriminant, B squared minus 4AC. In the first case, we got exactly 0, which means there's only one solution to the quadratic equation. In the second case, we got a negative number, specifically negative 20. If there's ever a negative under the root, it means we can't do it because we're not allowed to take the root of a negative number. That's why it leads to no solutions. Finally, in the third case, we got a positive number under the root, which means there's 2 solutions to the quadratic equation.